Hello. In this video we're going to look at the idea of amateurization. And basically amateurization is what a lot of you have used in the past. Anytime you're buying a home or buying a car or some large loan that you have to take out because you don't have the money right then to pay for that item is typically done using an amateurization and an amateurization schedule. So we're going to show you what that is, how it works, sort of how that schedule comes about, as well as how to use the calculator and formulas and the TVM solver to figure out various aspects of those loans. So let's go ahead and get started with that. All right, so let's start out with what is an amortized loan. I can't say it. Whatever. Amortized loan. All right. What is the idea there? Well, basically what you're doing is you're borrowing a large amount of money and paying it back typically monthly. And there's a formula for it, and it's even worse than the formula for annuities, although it does have a piece of the annuities in it. So if you look at the right-hand side of this formula, it's R times 1 plus R over N to the NT minus 1 over R over N. And if you're really into math, you go and see where they get this from. It's actually from looking at sequences and calculating sequences. But you can go ahead and just use it as well, or you can use the TVM solver if you look at this and say, yuck. So that's the right-hand side, and notice that does look a lot like annuities. But instead of having a P, or a future value over here, what we're going to do is we're going to use the compound interest formula on the left-hand side, because that's how we're going to get our future value. And that's going to be P times 1 plus R over N to the NT. So there's our formula. And all of these things are ones that you've seen before. P is your principal. It's what you're starting with, or what you owe. Your R is the interest rate in decimal form. N is number of compoundings per year, typically 12. T is your years. R is your payments again. All right, and same thing over here. So that's the formula. Now let's go ahead and look at an example and see if we can figure out how to use that formula, and then also see if we can figure out how to use the TVM solver to do that. So our example is we want to buy a car. And a used car that we found that we like costs $13,400. After taxes, fees, and your down payment, okay, you've got a little money, so you're paying that up front. You're going to end up taking a loan for $11,500. Your bank offers amortized loans for 5 years at 9% interest. So we're going to take that information and see if we can figure out what your monthly payment will be. So let's start by using that formula. Okay? So first of all, do we know what P is? The answer is yes. We know that we are starting out with a principal, or an owing amount, of $11,500. Do we know what our interest rate is? Yes. 9% interest. So that's going to change into a decimal. It's going to be 0.09 divided by N. It's monthly, so that's going to be 12. Raised to the 12 times, it's over 5 years. So our T would be 5. Equals R, our payment, and that's what we don't know, times 1 plus our interest rate, which is 0.09, over 12 payments per year, raised to the 12 times 5 years, minus 1, all over 0.09 divided by 12. Now, on this one, you could try and put the whole thing in your calculator at once, but there's lots of room for error there. So I would actually recommend just going ahead and doing each side separately. So if I do the left-hand side, I get 11,500 times parenthesis 1 plus 0.09 divided by 12, close parentheses, raised to the, remember we always have to put parentheses on our exponent, 12 times 5, close parentheses. On the left-hand side, I'm just going to write as many digits as I can so I don't get very much round-off error here. 33181. And then on the right-hand side, so just put all this in, I'm going to need brackets, numerator, and then within the numerator I have parentheses, 1 plus 0.09 divided by 12, close parentheses, raised to the parentheses, 12 times 5, close parentheses, minus 1, close the parentheses for the numerator, so here's the numerator beginning, numerator ending, divided by parentheses, 0.09 divided by 12. That's my denominator. And I'm going to write down as many digits as I can here, 75.42413693. And now notice I've just got a simple linear equation, so R is just going to be the division of those two things. So I'm going to plug that in my calculator, 18,005.33181 divided by 75.42413693. And it looks like I get a payment of $238.72. So that's how much I'm going to pay every month. Now let's see if we can do that using the TVM solver. So I'm going to write down what my pieces of the TVM solver are. I have N, I%, PV, PMT, FV, P/Y, C/Y, PMT. Okay. So my number of payments, that's going to be 12 times 5, which is 60. My interest rate is going to be 9%. My present value, on this one I do have a present value. I have my loan amount is my present value. So I presently owe $11,500. My payment is what I don't know. But what I want to have happen is I want to have this amount right now, and in the future I want to have that thing paid down to 0. I'm doing it monthly, so these are both 12, and we're going to just use AND for all of these. So if I go into my TVM solver, I'm going to plug in 12 times 5, 9, 11,500. I don't care what PMT is. 0, 12, 12, and end. Now I'm going to go back up to PMT. I'm going to hit alpha solve, and I get $238.72, which is exactly what I had over here. All right, so either way is fine. Now let's go on to the next question, which is, how much interest do you end up paying over the life of the loan? Well, first of all, we need to figure out how much we end up paying over the life of the loan. We're paying $238.72 every month, and we're paying that monthly, so times 12 times a year, times the 5 years that I'm having that loan over. And if I multiply that all out, I get $14,323.20. So over the life of the loan, I end up paying this amount of money. How much was the loan for? $11,500. So if I just find the difference there, that'll tell me how much I ended up paying in interest. Okay, because I paid off the $11,500, and then here's my interest amount. So if I subtract that out, I get $2,823.20 in interest over the life of the loan. Okay? All right. Now, just a kind of a follow-up question. Suppose that the car you were thinking of buying is a little out of your budget. Okay, you can't afford $238.72 a month. Let's say that instead you can afford payments of $180 a month. All righty? Let's find the loan amount for a monthly payment that you can afford. So instead of, we could go ahead and use the formula for this one, okay? And for that one, we would be plugging in an R and we'd be solving for P. And if you'd like to do that, I'll let you do that. But basically, you'd be plugging in an R value here of 180, and then you'd be solving for P. So if we did that, we would have, let's see here, you'd have whatever this piece is. Yeah, I'll let you go ahead and do that because I want to go the easy way. All right? I want to do it using the TVM solver. So if I do that, I'm going to say N I% PV PMT FV P/Y C/Y PMT. This is going to be end. This is going to be monthly, so it's going to be 12, 12. My future value is still going to be 0. Now I know my payment, and since it's coming out of my pocket, I'm going to use negative $108. My present value is what I don't know, how much I'm going to take the loan out for. I do still have the 9% interest, and I still have the 60 payments over 5 years. So if I go to my PMT, or go to my TVM solver, I have the 60 already, I have the 9. I don't know the present value. I'm going to plug in a payment of $108. I want to get down to 0 monthly. So now I'm going to go up to present value, and I'm going to hit enter and solve, and it says I can afford an $8,671.21 car or loan. All right. So once you have it in there, you can do a lot of different things and sort of ask a lot of different questions. The next piece I want to look at is how to construct an amortization table. And what I've got here is a table that I've laid out for you, and you can see that on the notes that you print out. I'm just going to find a couple of, or one line in addition to the ones I've already got worked out here, and then let you fill in the rest for practice. All right, but let's say that we're going to go back to that original car that we were borrowing $11,500, and we were making payments of $238.72. What we want to do is we want to see what happens with that payment. How much of that payment goes to interest, and how much of that payment goes to paying off the balance, which we call the principal paydown. So what we can do is the following. We look at the first month, okay, and we know that our payment in the first month is $238.72. To figure out how much interest we owe for that month, we're going to use, notice this is simple interest. This is P, R, and T. We're going to take what we owe, which is $11,500, times our interest rate, which is 9%, times our time, which is 1/12 of a year. And when we multiply that all out, we get $86.25 is how much of that payment is going to interest. So if that much is going to interest, and of course you always pay interest first. Banks are very interested in getting their money back. Once you've paid your interest, then you're going to take what you paid total minus the amount that goes to interest, and what's left over is going to pay off your principal or your balance. So then when you go over to your balance is going to be $11,500 minus how much you paid this month, and this is going to be your new balance. Then you go to the next month. And at the next month, you've got this as your new balance. You no longer have $11,500. You now have $11,347.53. And you want to find the interest that you're paying on that. So you take that principal times the rate times the time, and here's the interest that you're paying in the second month. Then to figure out how much of that goes to pay off principal, you take your payment minus how much went to interest, over here, That's how much went to pay off principal. And then you can take what your principal was from here, subtract off how much you're paying, and this gives you the next value. So if we go to the next month, we'll just do one more month here. What we would do is we'd start off with finding out what our interest is, and we would do that by figuring out what our balance was from the last time, which is 11,193.92. So we'd take 11,193.92 and multiply by the interest, 0.09, times the time, which is 1/12. And when I did that on the calculator, I got, and I rounded it off to the nearest cent, $83.95. So that's how much is going to, yes, that's how much is going to interest. Okay. Now I can figure out how much is going to principal. So I take my $238.72 minus the amount that went to interest. Oops, $83.95. And when I did that on the calculator, I got that we're going to pay $154.77. And then our balance is going to be 11,193.92 minus the $154.77 that we paid. And my new balance is going to be $11,039. And you can keep doing that for month after month after month. Now, you can also do that using a lot of different programs. There are macros that you can download for Excel that will do this. There are websites that will do this. What I put on the Blackboard site is a website called Bankrate, which has this amortization table on it and allows you to find that. So let me go to that real quick and show you that. Hold on. Okay, so I have the website up, and I will have this link on Blackboard. But what I'm going to do here is I'm going to go into the mortgage calculator. I'm just going to plug in the amount. So the amount we were dealing with was $11,500. Our term here was 5 years. Okay. And our interest rate that we were looking at is 9%. And then it doesn't matter when you start. But what I want to do now is I want to calculate what my monthly payment's going to be. Okay, and it calculated it for me. And notice it's the same thing as what we got. All right, so we got $238.72, same as what they did. Alrighty. So now what we want to do is, this is a part if you want to make extra payments. Kind of nice if you want to, if you do have a loan and you say, hey, I can add an extra $100 a month to it or whatever, you can kind of see what that's going to do. But let's go ahead and show or calculate the amortization table. And if we do that, here's our amortization table. And if you look at what they've got there, it looks very similar to what we were just working on. We've got the principal paid, $152.47, same as we had. Interest paid, $86.25, and here's the balance. Notice what's kind of nice is they keep a running total of how much you're paying in interest. So you can actually scroll down to the bottom and see how much you paid in interest over the life of that loan, and you will notice that it's the same as what we calculated, the $2,823 over the life of the loan. So kind of nice to have. You can also go ahead and take pieces of it and just right-click and copy that and paste it into any document that you're interested in. Okay, so real nice feature to be able to use. So I'll let you play with that and figure out how to use it. In the meantime, let's go ahead and go back to our last bit of notes on this section. So hold on a minute. Okay, so the last piece that we want to look at here, and this is going to be helpful when you're working on your written assignment for this chapter, is the idea of refinancing a loan. So in order to refinance a loan, you must know the unpaid balance on that loan. So let's say we've got the following. Assume that you take out a 30-year mortgage for $150,000 at an annual interest rate of 8%. If, after 10 years, the interest rate drops to 5.25% and you want to refinance, how much remains to be paid on your mortgage? All right, there's a couple different ways you can do this. Let me just show you a couple. One is you can use the formula. And in order to do that, you'd use a little variation of the formula we saw before. You'd say U, which is your unpaid balance, is equal to P times 1 plus R over N to the NT, which is your future value at whatever point you're interested in, minus your payments that you've already made towards it so far. So you could use that formula if you wanted to. I'm going to choose not to, because you could do something else as well. You could use your TVM solver. And in order to do that, we've got N, and we've got I%, PV, PMT, FV, whoops, and all the other stuff is the same. So I'm going to start out by figuring out what my payments are going to be. All right, so I'd start out by saying I've got a 30-year mortgage, so 30 times 12, which is 360. My interest rate is 8%. My present value is I owe $150,000. My payments are what I don't know, and my future value I want to get down to 0. So if I do that on the calculator, alrighty, I'm going to plug in 360, 8%, $150,000, and I'm going to get down to 0. I don't know what my payments are going to be. My payments are going to be $1,100.65. So $1,100.65 for payments. Okay? So that's what I'm going to be paying every month. Now, I could do that. So now what I can do is I can modify that and say, okay, well, now I've not gone all the way through and gone to the end. So I can leave that in there and redo my TVM solver. And now what I'm going to do is I'm going to say, all right, what's going to happen after 10 years? So after 120 payments. My interest rate is still the same. My present value is still the same. My payment, I found, is minus $1,165. And what I want to calculate is how much I owe at that future time, after 10 years. So if I put that into my calculator, I'm going to change this to 120. Okay. I'm just going to go ahead and round this off. And then I'm going to figure out my future value. So I'm going to hit solve and enter. And it tells me that I've got $131,586.48. Okay. Now you could also go to the amortization schedule on that mortgage calculator, and you could actually look down and see what the balance is after 10 years. So the other thing you could do is you could go back here, and you could put in your mortgage amount of, what did we say it was, 150,000? Make sure I got enough zeros there. Okay. And our mortgage term is for 30 years, and our interest rate is 8%. We can calculate our monthly payments. Which is what we got. And then we can show the amortization schedule. And then you can go on 10 years and find that value. So notice 131,586. Okay, they're a little bit different than me, but pretty darn close, and that's in 2020, February of 2020, and we were starting in February of 2010. So there's the value after 10 years. Okay, so either way. Alrighty, so let's go to the next question, which is, what will your monthly payments be if you refinance for 20 years, for the last 20 years, at a rate of 5.25%? All right, so again, I'm going to use the TVM Silver. And my number now is going to be 20 years times 12, or 240. My interest rate is now dropping to 5.25%. My present value is now this value up here. I now owe 131,586.48. I want to find out what my new payment is, and again, I want to get my future value down to 0. So if I do all that on the calculator, 240, 5.25, 131,586.48. I want to get down to a future value of 0. My new payment is $886.69. Okay, $886.69. And now my last question is, how much will you save in interest in the 20 years instead of by paying the lower interest rate? Well, if we look at how much we would pay over 20 years using this first rate up here, okay, we were paying $1,100.65 every month. So if we look at how much we would pay over the 20 years for that amount, we would have 1,100.65 times the 240 months that we're looking at. And that gives us a value of, times 240, gives you a value of $264,156. And if we're paying the new rate of $886.69 instead for those last 20 years, 886.69 times 240, you get 212,805. So if you look at the difference between those, 156 minus 212,805. Oops, put my decimal in the wrong place. 264.56 minus 212,805.60. We're going to save $51,350.40 over that 20 years. Now, one of the things that you may find interesting as you're working through the written assignment for this is to calculate how much you end up paying over the life of a loan if you're dealing with a house. For instance, up here on this one, if you were to keep this loan for the whole time period and you were paying $1,100.65 every month, for 360 payments, you end up paying 1,165 times 360. You end up paying $396,234 on a $150,000 mortgage. Okay, so more than double, okay, almost double and a half, or more than double and a half, over the 30 years. Whereas if you do it over a 15-year, the amount you pay in interest is going to be much, much less. And notice, if you look at how much you still owe after 10 years, you've dropped less than $20,000 off that mortgage, because the first 10 years you're paying so much interest. All right, and you can actually see that when you go look at the amortization schedule for a home loan. So that may be something interesting you want to check out as well. Hope that helps.